And then towards the end, 15 minutes, I have an online form. If anybody who's interested can fill out their own reflections on this topic and maybe what they would like to do with it. This is something, of course, it's completely voluntary for the audience. If you want to, fill out this form, that would be really great, because then we can have a discussion at the end about it. I can sort of take everyone's different opinions and throw them into the generative AI, into ChatGPT in this case, and get some analysis, and we can have an interesting discussion about the topics of today. But if you don't want to fill out the form, you just want to write something for yourself and share it later, that's okay also. Or if you just want to take a break, you will have 15 minutes. But it was important for me to give everyone a chance to reflect on what I'm talking about, and not just listen to me talk for an hour and a half and then be done. I'd like to have a bit of a two-way conversation. So I'm going to launch directly into the motivation and the background. So this is the context and the background for why is this topic important, and what are the various terms and definitions that we need to know before you can get the full benefit of the examples that I'm going to give you. So one very important bit of context is what's called a VUCA world. VUCA stands for volatile, uncertain, complex, and ambiguous. And there is this idea that for the past 10, 20, depends when you want to start counting it. You can even count it from about 30 years ago, from the beginnings sort of the internet, that the world has become quite volatile, uncertain, complex, and ambiguous. And in this kind of world, the education systems also need to either reform or transform, or at least adapt in some way, in order to prepare students for this kind of world where things are not quite as predictable as they used to be. Certainly not in terms of a career, in terms of the job market and so on. And this kind of reality creates a lot of problems, a lot of challenges, which our alumni are then required to tackle when they go out into the real world. And one type of problem that I have been focusing on, and that I feel is somewhat neglected in higher education, and not just in higher education, also at schools, is what's called ill-structured problems. So the ability to identify these kind of problems and then find ways to address these kind of problems. So what is an ill-structured problem? It has other names also. You might hear ill-defined. You might hear it relates to wicked problems, complex problems also. So these are authentic real-world problems that are multidisciplinary, as real-world problems usually are. They are complex, including multiple components and interrelationships. They have many potential solutions. There isn't just one or a small number of very clear solutions. And what makes a good solution, the criteria for success, is actually subjective and negotiable. So if we take, for example, the problem of generative AI in education. So we have today a problem where in some institutions, at least in some countries, we believe there's a number of students who are using ChatGPT, for example, for various activities to do with learning. I'm not even talking now about cheating or things like that. I'm just talking about using ChatGPT to go over material, to learn, and so on. So we have that going on, we think, but we don't really know what the students are doing. Some of them are telling us, some of them are not telling us. And this, of course, could cause all kinds of problems, right? So that's an example of an ill-structured problem, because what the problem exactly is needs more exploration and more definition. It's not a clear-cut definition of a problem. What would make a good solution for this problem is not immediately clear. It's something that we as educators need to discuss. What do we actually want to get to, right? What is the state, in which the situation is better, and how to get from the problematic state to the solution state, how to get from where we are today to where we want to get to. There's no recipe, there's no algorithm, there's no particular method or tool that will get us there for sure. We need to figure that out. So that's an example of an ill-structured problem, which needs to be structured before we can address it effectively. So here's an example of an ill-structured problem, and this is not an example from education. This is an example from the business world. It's actually a real-world example of an organization I worked with, which was a biotech startup. But this kind of example, of course, could be relevant to a project that the students are working on, or you could put anything else in its place. This happens to be a kind of an operational problem to do with lack of efficiency in how this company is running their experiments. But it could really be a lot of other things. It could be things like how to choose your degree or how to choose your major as a student. That's an example of an ill-structured problem, because it's not always clear what a good decision is, right? What does it mean to choose the right major for you, for example? Another example could be extreme heat waves that are affecting a city a few times every summer and are causing all kinds of problems in the city. And let's say because of how the climate is going and so on, there are some cities in the world that are being affected more and more by extreme heat waves. What do we do about that? So these are all examples. And as you can see, ill-structured problems tend to be quite general. You can take them into all kinds of directions and so on. They can be very big, they can be very small, but what's connected, what's in common to all of them are all these attributes here. So this is, again, where I'm coming from, where teaching problem-based learning is not just because it's a method that can be used to teach concepts and so on. It's also a method that can teach students how to address ill-structured problems, which is a really important ability. And this relates to higher order thinking, because part of complex problem solving or solving ill-structured problems require us to use higher order thinking, which is complex, non-algorithmic, handles uncertainty, generates many solutions, and depends on self-regulation. And these are all examples, not exhaustive list, not a definitive list, but just some examples of higher order thinking skills. Some of which might be familiar to you, some of which less so. But as you can see, they have a lot to do with problem solving, and they have a lot to do with trying to tackle the problem through various means. So when we talk about high order thinking, if any of you are familiar with Bloom's taxonomy, there is also the Anderson sort of adaptation of Bloom's taxonomy from nouns to verbs. I put them both next to each other, again, just to show you what you're seeing at the top are things that are related to high order thinking. So things like remembering, understanding, comprehension, they are not high order thinking. They are lower order. They're more to do with memorizing facts and so forth. Whereas things like evaluating our own work or other people's work, creating new things, even doing analysis, these are more higher order thinking. And they relate to this list here. So again, this idea of VUCA world, volatile, uncertain, complex, and ambiguous, poses us with a lot of ill-structured problems, a lot of complex problems, and this requires us to be able to have and exercise high order thinking. And indeed, this has been recognized as important by many educational bodies, economic bodies around the world, national bodies in the US, and so on. Now, it has been reported many times that active learning can help teach these skills, can help teach students how to address ill-structured problems, can help develop their high-order thinking skills, and so on. And this has been recognized by education bodies. That's generally saying we need more active learning in the classroom. So what is active learning? So in active learning, students engage with real-world problems, cases or questions. They apply higher order thinking to those problems or questions. They carry out discourse among themselves and with the instructor. So active learning is not a solitary learning activity. It's not like, watching a lecture at home or a lecture video or something. And finally, reflecting on your learning. So there is a loop, there is a cycle that is closed, right? You apply something, you talk about it, and then you reflect about what you did. and then you plan for the next time. So this is, generally speaking, what active learning is about. And as you can see, active learning matches very well with Merrill's principles of instruction. So what Merrill did, and you can read the paper also from 2002, is survey a very large number of different educational theories and approaches and found what is common to the majority of them. And as you can see, the attributes that are mentioned here are very much related to what we just described for active learning. And there are, of course, different types of active learning. And what I'm showing here in this slide is my own classification, just to help us have the discussion. I'm not claiming that this is the dictionary definitions here, but just to give you a better understanding of what I mean. Maybe some of these things are more familiar to you, these different types. So we have, of course, problem-based learning, which is mainly what we'll talk about today. So problem-based learning is about ill-structured problems usually, and giving the learners more autonomy, giving the students more autonomy about investigating the problem, exploring the problem, then defining the problem, and then trying to find a solution to how they define the problem. Whereas if we take something like case-based learning, the problems are more well-defined. There's less autonomy for the learner. But the common thing between problem-based learning and case-based learning is that it usually takes days to weeks, and the focus is on applying knowledge. It's not necessarily on creating new knowledge. And inquiry-based and project-based, again, as you can see, they usually take longer. They focus more on creating new knowledge. What a lot of times happens in project-based learning is that we give the students a project that is quite well defined, but at the same time, we give them a lot of reading materials, or there's a new skill that they have to pick up, and so on. So there's a lot of knowledge creation as well. So these are, you can think of, and there are other types as well. There's challenge-based learning, and there are other types, but I kind of just showed you the main ones and the two axes, right? So we have learner autonomy and how we'll structure the problem is, but we also have how long it takes and whether the application is knowledge creation or knowledge application. And of course, there can be a mix of these things. It doesn't have to be extreme one way or extreme another way. And there are many challenges, actually, in implementing active learning. I believe perhaps the main reason that active learning doesn't take place in more institutions today is not because instructors aren't aware of the fact that active learning can be useful and helpful and develop all these skills that we talked about. The issue is, I think, that it's difficult. The pedagogy of active learning is a lot more difficult than traditional pedagogy. So what I'm doing here, which is, giving you a lecture, maybe running a small activity at the end and answering some questions, it is easier, it is simpler, it is less advanced, less complex as a pedagogue, as an educator, as a teacher to do than to do active learning. So all the stuff you're seeing here, and probably more as well, pose a challenge. And the work that I'm doing with developing frameworks and pedagogies, but also with the generative AI, is meant to help with these challenges. Is meant to reduce the pedagogical expertise, reduce the pedagogical obstacles towards active learning. And finally, we want to talk about generative AI. So LLM is a large language model. And when people say AI today, this is what they're talking about. They're talking about the LLM-based general purpose generative AI, like ChatGPT, which is the leader today and having the most users. But there's also Gemini by Google. There's Perplexity by Anthropic. There's Claude, and so on. So there are, I'm sure you know, even more names of these kind of generative AI applications. So they can take as input and put out as output. It can either be just text, but it can also be multimedia, like images and videos and so on. And they are trained on the web. So there's about 4% of the web. It's called the pile. And these general purpose LLMs are trained on that. Now, it doesn't mean they're only trained on things from the internet, but that's the bulk of the data that they are working off of. So I just want to point out, when I say AI or generative AI, I'm talking about this particular AI or generative AI. And of course, generative AI has many potential uses in teaching and learning. And today I'll go into some specifics, but just to be very general, it can help us to prepare materials for teaching and learning. So for us and for the students, it can help facilitate the learning of students in all kinds of ways, and it can help us evaluate the students' learning and provide them with feedback. And it can help us along 3 axes. It can make our work more efficient. It can make our work more effective or higher quality. And it can also help us do new things that we weren't able to do before as teachers. Now, that's not to say it's all good, and it's not to say that there isn't a lot to learn, and there are cases where it works better, cases where it works worse. We will talk about that. But these are potential contributions. And this is an example of 2 figures that I've taken from a paper I recently published with 2 colleagues of mine from Aalborg University. And what we did there was we did a review of all the literature involving generative AI in active learning in STEM, science, technology, engineering, math, STEM education. So we went from high school all the way to graduate education, papers in English from across the world. And as you can see, we ended up having 50 papers in the final pool after we filtered everything out. And what I want to show you here is that when it comes to active learning, at least in STEM, you can see that the main studies have focused on problem solving, critical thinking, computational thinking. These are the main studies. And in terms of the roles of the generative AI, this is something interesting that we found, that you can put it in always into one of 5 categories. So sometimes we, in education, when we use ChatGPT in the classroom, so this is based on these studies, right? It's either used as a tutor, or as a co-creator for the students, or as a processor of data and information, or as a coach that's coaching them through an assignment, but is not teaching them the material, or as a simulator to simulate some kind of situation or some kind of environment. So that's pretty interesting. If you are planning, to use generative AI in your classroom, it's worth thinking about what are the skills that I want to help develop, and also what kind of role do I want the generative AI to have. Not just, generically or arbitrarily, oh, we're going to use generative AI, but how exactly do I want generative AI to interact with me and with the students? In what capacity? As what role? So that's what has to do with the background. And I'm asking if you have any questions, please put them in the chat. And Maipal or somebody else, maybe you could divert my attention to questions, just because I can't see any questions when I share my screen. So if you have any questions for me, anything not clear, anything you'd like me to expand on, please write them down, and we will get back to them. So now I'm moving to the first example, where I'm talking about a pedagogical framework for teaching systems thinking and how I use generative AI to do assessment for this. So systems thinking is one of the higher order thinking skills that we were talking about before. And as you can see, it's quite neglected when it comes to the education research part. So as you can see here in the chart on the right, systemic thinking is another name for systems thinking. Systemic thinking is the extreme right. We actually found very few studies that use generative AI in systems thinking in the classroom. But it is a very important skill, especially, again, as the world is becoming more complex. So just very quickly, what do we talk about when we say a system? So an artificial system or an engineered system can be said to have a structure, a function, and a purpose. So anything, whether it's a pen or a motorbike or this platform that I'm talking to now, these are all artificial systems. Artificial can be technological, can be social technical. But they all involve, they have some kind of a structure, and they do something in the world, and there is some kind of purpose for which they are made, one or more. So some problem or lack or demand or something that we want to address with that engineered system. However, natural systems do not have a human prescribed purpose. They are not designed per se, at least not in the sort of empirical mental framework that we're approaching this with. So that's a very important distinction when we teach systems thinking. And the framework that I have worked on is a framework for engineering students, and specifically to look at artificial systems. So the obstacles that I had, and the reason why I had to develop my own framework for teaching systems thinking, was that I could not find frameworks which are appropriate for novices. I teach a first-year class, so these are students in their first semester, and they could be from any major, from any degree of engineering or even science, natural science, exact science. So I need something appropriate for novices. I need something that I can both foster systems thinking, develop systems thinking, but also do an assessment and give feedback. I need something which is domain agnostic within engineering, so it's not specific to systems thinking in electrical engineering or mechanical engineering. And finally, it needs to be scalable and adaptable to various learning objectives. So this framework needs to allow me to be able to develop different types of assignments for different types of scenarios in different classes. And this was the framework that I developed. And there are papers that you can read and so on. But just briefly to explain, it's called SAFO, System Architecture Function Outcome. And the idea is that to introduce systems thinking, the very basics of it are to think about these three things, are to think about the architecture of the system, the function of the system, and the outcome. So the architecture of the system is simply the structure, so the parts of the system, and then how they interact together. So if I take, for example, let me just quickly grab something simple, a simple system. Simple architecture. So I have this pen here. So this pen, of course, is made up of parts, and they interact in some way. Okay, so if I'm able to describe that, that means I understand the architecture of the system of interest. But the pen also has a function, which is what it does. And the pen actually would be completely useless if it was just an architecture on its own. The pen also needs the boundary systems that interface, that interact with it. So my hand, for example, provides input to the pen. And there is also a surface that the pen needs to write on. Not every surface is suitable. So now I need to take into consideration the inputs and the outputs. And that has to do with the function of the system. So all those interactions need to occur in the right way in order for the pen to deliver its function. And finally, the outcome is, why do we care that the pen exists? Why do we care that the pen functions? Well, we care because it has a specific purpose. It helps solve a specific problem. In this case, it's the problem of, us wanting to write something down, but not spend a lot of money on the ink, for example. So the modern pens, unlike the very old ones, say from 100 years ago, the ink is very cheap. You can use them for a very long time. They're very convenient. It's more legible, more visible than a pencil, and so on. So you can start thinking now about what is the purpose of a pen, right? So to describe systems within this framework, you start off by describing the architecture, the function, the purpose, and finally, and this was a new addition that I added a couple of years ago, is the detriment. So any system that is designed in order to solve a problem or fulfill a need also causes some kind of detriment. It might cost more, it might require you to extract more resources, it may cause a potential safety hazard, it may cause pollution, and so on and so forth. Something very important that I stress to the students is that when you are thinking about how to solve a problem, you also have to always think about what other problems that I'm going to be causing by doing that. And then is the trade-off worth it? Is this value more important than this value? Can I mitigate for those potential problems that I'm causing. And this is an example of a diagram of the architecture of a bicycle. Okay, I used it red, but you can use a different color, but just to show as an example. So it's just a box and arrows diagram, right? It's pretty simple in this framework. So this is what I actually ask students to do. I either give them a system to read up on, or I give them a list to choose from, like Wikipedia articles, or they choose their own project, or whatever it is. And this is now a diagram showing the architecture and the function. So the architecture is in red. That's our system of interest, the bicycle that we're focusing on, that we want to know really well. Maybe we are redesigning or building a new bicycle. And the blue are the boundary systems that interact with our architecture. In this case, we have the human cyclist and we have the cycling lane where the bicycle is rolling on. So you can see this whole diagram together shows you essentially how the bicycle functions. And this is a summary of the bicycle architecture, function, and outcome. So the top two, system architecture, system function, the text is taken directly from the diagram. It's exactly the same. And at the bottom, we see the outcome. So who are the stakeholders of this problem? What is their problem? What is the benefit that a functioning bicycle gives them? And what is the potential detriment? So we say, oh, there's a more vulnerability to dangerous accidents if you're on a bicycle. So all of this is debatable. You give this to one group of students, they might think of other major parts of the bicycle. They might not choose the 5 parts that I have here. They might call the interaction something a bit different. They might look at other boundary systems. They might look at other outcomes. That's perfectly fine. That's part of the discussion. The idea of this framework is to try and choose the major and essential elements. So what are the main parts and interactions? What are the main input and output entities or systems? And what is the main outcome? And this is, again, all part of a discussion. The idea is to learn. This is not a framework for system engineers or for industry to develop robotic systems. This is a framework, a pedagogical framework for teaching systems thinking. So here is an example from a real course that I taught in spring 2022. And what you are seeing here is a system that was designed using this framework. So instead of going this way, architecture, function, purpose, detriment, we started with a purpose. What is it that we want to achieve? And then we work backwards. So here is an example of, okay, we developed at MIT this brick. It's about this big. It's about the size of a shoebox. And it's made of stainless steel, and inside it has molten salt. Very hot molten salt gives out heat for 6-8 hours. We want to use this to replace coal. There is the capital of Mongolia, Ulaanbaatar, is the coldest capital city in the world. It's also the most polluted in the winter because everyone uses coal to heat up their huts, their traditional homes, which you can see here. They're called a gur. So what we thought people at MIT, this was even before my time, let's make a low carbon, low pollution alternative. The issue is with transporting it. The issue is with logistics. It's actually very difficult because the terrain is very rough and you have to get it into all the different houses. And now the question is, how are we going to do this? So the students came up with a kind of a trolley, as you can see here, like a trolley solution, where there is a little hole in the fence to put the garbage through. There is a fence around these houses, and there's a little hole for the garbage. So the idea is, okay, let's put the trolley next to the hole. Someone can come from the outside, a delivery person, put the new brick on this trolley, and then I can take it inside my house. So this is an example of using this framework in order to come up with this kind of solution to a problem. And now we get very soon to the generative AI. All of this is very good, but we need to give students feedback on the work that they're doing. So if I'm giving them this system, or I'm giving them this system, or giving them a bicycle, or whatever it is, I want them to come up with all of this stuff. I want them to come up with all these diagrams. And maybe then I want to ask them, okay, based on everything that you've come up with, can you suggest ways to improve the bicycle? Can you suggest ways to increase the benefit that you found or reduce the detriment that you found by changing something in the structure, changing some part. Now, how will that part change the interaction with other parts? How will that change the functions, the inputs and the outputs, and so on? If I want to ask them and to work on all this stuff, I need to be able to give them feedback on every single element, on what they wrote for structure and what they wrote for behavior. And how do I do that? Well, the problem with assessment of this kind, formative assessment, feedback, is the time that it takes. That's the main issue. Another issue is that sometimes we don't have a very detailed rubric, that the feedback that we give is not very detailed, is not really very useful. So the first thing I did, of course, together with my colleague Bertel, is to create a very detailed rubric, which we're not going through today, but is very detailed for every system element. So every one of these elements, structure, behavior, input, output, problem, stakeholders, benefit, detriments, all of these has a very specific guidelines, whether you give a score of 3, which is the best, a score of 0, which is the worst, 1 or 2. So there's 3, 2, 1, or 0 for each one. Now, again, the issue is the time that it takes. So what I can do is I can actually use ChatGPT to go through all of that. So this is an example of just one instruction for one of the system elements, which is input. So as you can see, you have certain terms that you have to keep in mind. You have certain questions you need to ask. And then based on those questions, you give a score of 3, 2, 1, or 0. The score is not really important. What's more important is the feedback of how they can then improve what they've done. And this is just based on following the rules of the framework. It's not based on whether what they wrote is correct. Correctness, we also have a rubric for that. Those are different instructions that you're looking for, whether something is correct or not. So if I'm looking here, for example, maybe they've mentioned the right number of parts. Maybe they've covered all the parts under the interactions. They've mentioned one input and one output system, and they've explained it very well, but it could all be wrong. Those are actually not parts of a bicycle, and those are not real interactions of a bicycle, and those inputs and outputs are not correct. That doesn't matter for what I call adherence, which is following the rules of the framework. So my advice to anyone here, if there is anything you want to teach, any skill, any concept, make sure you understand what you're looking for them to actually do, as well as what makes a correct answer. So there's following the rules of the assignment or the framework, but there's also the actual validity of what they wrote. And my suggestion is always to separate those two when you give feedback. So this is the actual prompt that I give the generative AI. Read through every section below in the following order. So the framework overview, which is what we've just been through together. Assignment instructions, depending on what your assignment was. And the actual rubric for assessing the adherence. And sometimes you might have additional materials you want to throw in, like you gave them an article to read, to pull out the information from, or whatever. So this prompt is actually a lot longer than what I'm showing you, because it now includes all of those sections, right? So it's about 6 pages or so, depends. Well, more like 4 pages. And then you can just feed it the students' answers. So here's an example of what it spits out. So it's looking at structure. This is for one submission by one group of students. Okay, so in this case, we gave them an article about salmon farms, fish farms in the ocean. And they had to take the information out of that article. And the article was about 3 or 4 pages. They had to take the information out of that article and describe the salmon farm as a system. That's what we asked them to do. And we told them you have to give these many parts, and then 5 to 7 parts that are the most major parts. And then you have to give interactions among all those parts. And then you have to give one input system and one output system, and so on. I'm asked to zoom in so that the content is visible. So I will do that for this. So here's an example. So it gave here a score of 3, which is strong. It explained why it gave that score. And it gave me a quote from the student response to make sure I understand why it gave that score. So in this case, it gave a strong score for all of them because this happened to be a very good response. But again, the idea is not just for systems thinking or any other high order thinking skill. If you have a detailed rubric where you explain in detail to the generative AI what it is that you're looking for, and you separate following instructions from whether something is valid and correct, if you just focus on adherence, you just focus on guidelines, that's something that generative AI can be very useful for, because you're not asking about correctness. You're giving it a very clear set of rules, and then you're asking it to check the student's responses based on that very clear set of rules. And here's another example for something that generative AI can be really helpful with, which is it's taken now all the responses that it analyzed, something like 80 responses. It tells me what the median score is for each one. And remember, the maximum is 3, the minimum is 0. So as you can see, some are 1s, some are 2s. None are great, none are 3, none are terrible, none are 0. And then it can map it to the maturity level. And this is just based on other theories of systems thinking, which I won't get into. It's got nothing to do with this framework. But it helps me as a teacher. And again, I can engage with other frameworks, with ChatGPT, to give me sources and so on, to tell me, okay, this is where your students are right now. Here are some examples of assignments that you can give them to further develop this ability. And again, it's given me here, different types of systems thinking activities that I can engage the students in order to increase their ability across different aspects. And like I've said before, this doesn't have to do with systems thinking. It can do with anything really that you want to teach them, especially transdisciplinary domain agnostic skills. So the important thing is to work or take another person's framework, which has detailed instructions and detailed assessments. And then you can put that into something like ChatGPT. But if you just randomly give ChatGPT the student responses and you ask it to give an evaluation, it's going to be all over the place. It's going to give some, opinions. It's going to focus on certain things and emphasize certain things which might not be that important to you. So having a rubric is very important. And these are some peer-reviewed studies. If you are so interested, you are welcome to check them out. And by the way, I will provide this PDF of the presentation afterwards. So you don't have to worry about memorizing everything. And of course, this is recorded anyway. So the next example I want to show you has to do with problem structuring, which is a term that some of you may have not heard before. I'll explain what it means. And also, of course, how I use generative AI within that. So first, why is it important to structure problems? So I discussed before ill-structured problems, right? So just to quickly remind you what those are. So ill-structured problems, again, these are real-world problems. They're multidisciplinary by nature of being real-world problems. They're complex. They include multiple components and relationships. There are multiple potential solutions, and we actually have to agree on what makes a good solution. Do we care about cost of manufacture? Do we care about safety? Do we care about inclusivity and usability? Maybe we care about all those things, but we need to prioritize them. That's a whole discussion. So these are ill-structured problems. And an important thing to do with an ill-structured problem is to structure it, of course. And if we don't do that, and we just rush into solutions, which is something that happens too often, well, we are going to have to correct a lot of things down the road, and that's going to come at a high cost. We might not comply with regulations when we are creating a product or a service, or even a new course at the university. We have all kinds of opportunity costs. We are maybe working on the wrong problem or have a wrong understanding of the problem. Meanwhile, we could be working on other things. And, we could be misallocating our resources and so on. And the motivation for developing the problem structuring method I will share with you is actually very similar to my motivation for developing the framework for introductory systems thinking. I wanted something which was transdisciplinary. I wanted something which was appropriate for novices and that has a basis in the research. So it's not just something that I'm making up, and that is also scalable. But again, I just couldn't find anything like that. If you look up problem structuring, you will find that it's something that's usually being done in government. It's being done in sort of very advanced, graduate studies, or pay consultants a lot of money to come in and do that, but not something that you can really teach to students in the undergraduate level. So the DIMES method is a method for problem structuring and for teaching problem structuring, but it's also a PBL method. It's a problem-based learning method. So you can actually use it and add to it any other concept or skill that you want to teach to students into this kind of method. And the way it works is, firstly, you describe the problem in a brief way using plain language. So this is kind of just like a thread that you start from. A lot of times the difficulty with ill-structured problems is, where do we start? So here it makes it pretty easy. You just start with 50 to 100 words in plain language, however your team understands the problem. And with the understanding that it's going to be limited and it's not going to be exhaustive, some of it's not going to be correct, we will work on that in the subsequent steps of the method. So after that, step number 2 is where the students write a problem case. It's like a case study of the problem. They answer the who, what, where, and why questions about stakeholders and effects and locations and periods and causes. And this is where actual references and sources and reports and surveys come in. And then stages 3 and 4 have more to do actually with systems thinking. You take this problem case, this case study, and you represent it in a conceptual hierarchy. And then you look for efficiency points deep within the problem where you can impact the problem in a big way without putting in too much effort. So this is very much a systems thinking approach. And finally, you create a problem statement. And the problem statement is a well-structured problem. So now it's a problem that we can understand how to approach in terms of the methods or the tools. And we also have a much better understanding of what a good solution looks like. And the problem statement is really just a summary of the 5 W's from the problem case, from number 2, and the efficiency points deep within the problem from number 4. And if you want, there is actually a shortened version of this up on MIT OpenCourseWare, which you can play around with. It only includes steps 1, 2, and 5. It's kind of a simplified version that I worked on with MIT libraries, specifically for students to just do on their own. So here's an example of a problem description versus a problem statement. So on the left, I actually already showed you this before as an example of an ill-structured problem. And again, this is a real-world ill-structured problem that I worked on with a real-world biotech startup. And on the right, you can see the end product of the DIMES method. DIMES is describe, inquire, model, extract, and state. So problem description is step number 1. Problem statement is step number 5. This is the summary of the problem case of the who, what, where, and why. So there's 5, 6 pages answering these questions with references. This is the summary. So it's still an overall broad, big problem, but you can see already much more clearly who the stakeholders are, how are they affected, what are the locations and times in which this happens, and what are the causes for why this is happening. And this is work that I did with the people at the company. Now, I also have a GPT that I set up, just like I did for the SAFO, for the systems thinking framework. I also have one for the DIMES method. And I'm not going to explain how I came up with these numbers that you see here, but what this did is take the problem model. So again, we had the problem case, right? Which is the 5 W's: who, what, where, when, and why. Then we took that and we converted it into like a pyramid, like a tree of functions, and kept breaking it down and breaking it down. And we got to 5 levels of depth. And I just have a formula, and the DIMES application expert, the GPT, calculated the formula and ranked all the processes for me and said, okay, 1331 is your winner. That's your biggest efficiency point. That's where you have the most effects, the most impact on the problem, but the least effort. So the fewest stakeholders, the fewest locations, the fewest periods, the fewest causes. So you can really have a big impact on the problem with relatively small effort or low cost. So as you can see, we have here all the different levels, like deep functions that are level 4 of the model, and they are ranked according to how much effect they have on the problem versus how much it would cost to actually take care of them. So you can think of all of these as separate problems in a way. And now what I can do is I can take, say, the top 2 efficiency points and summarize them. So what you're seeing here on the right is a summary of these 2 efficiency points. And as you can see, this is a much more high resolution focused problem than the one we have here on the right. The one we have here on the right encompasses many different types of stakeholders. You know, it's good to know, it's useful, it's part of your problem statement. But in terms of your focus, you are now focusing on a specific substep and on specific stakeholders. So this is the idea here. And as you can see, the generative AI can be very helpful in expediting this. So for example, again, in step number 4, extract efficiency points, it can just do it for us. So when you have a method that you've come up with, and it has some steps which are algorithmic, which are just a recipe, you can use that to automate that. But you can do more than that. And I'll show you that in a bit. So using funding from Day-1 Education Innovation Grant that I received, I actually developed a platform which is available to use. And by the way, it's free to use until the end of the year. So if anybody's interested in using this with their class, just get in touch with me. I can set up a project for you. We can do research together if you want. In any case, you can just use it, this platform. So this platform is cloud-based for PBL management, and everything that I showed you today is included inside this platform. So you can decide where to start, where to end with your students to do PBL, problem-based learning. It goes beyond problem structuring. It goes into ideation as well, and we're using generative AI for that too. This is how the actual workspace looks like. So as you can see, this is specifically the inquire step. It's a little bit like Google Docs or Microsoft Office, but it's on a platform where you don't need a special email. You don't need a Gmail or a Microsoft email or anything. You can use any email address. You have a chatbot, which is connected to OpenAI GPT through the Microsoft Azure. And you can actually ask the chatbot to give you adherence feedback on your document. So am I following the rules of the method? Am I following the rules of this step? And the chat bot can immediately give you feedback. You, of course, also have assessments and other things that you can give, the instructor can give, and so on. So this is an example of an assessment form that's inside the system. The instructor can submit assessment for each step. The students can submit. And again, you can also ask the generative AI to give you its own feedback as well on adherence. So notice I'm going to focus here, zoom in. you can see it says adherence and correctness. So I'm again repeating this idea. Adherence is following the rules of the step of what you're supposed to do. Correctness is the validity of what you wrote, is how correct is what you wrote. Two different things. And I trust the general purpose LLM like ChatGPT to do this because I'm giving it a very detailed rubric. I'm not trusting ChatGPT to tell me whether what they wrote was correct. That's for the expert. That's for the instructor. And there are, again, the rubrics are very detailed also for the instructor. And there are also reflections. So we talked before, active learning has to involve reflections by the learner. And each step here also has a reflection. Did you understand what to do here? Did you find it useful? Did you think you worked well? Did you think your team worked well? By the way, people are saying they use the link and it's not working. I'm assuming they mean this link here. This will take you to the landing page. You will not be able to register or log in without an invitation from me. So if you want to actually log into the system, do get in touch with me by email, and I will very happily create a project for you. So what does Seed AI do in Dimes? Seed AI is is the name of the platform, but there is actually generative AI, as I showed you. So if we go back to the 5 different roles that I showed you before, if you remember, we have 5 different roles for the generative AI. So in this case, it's a co-creator and a processor. So you can give it a problem statement and it will suggest ideas and ways to think about different ideas for the problem. This is after problem structuring. And it also does processing because it can do a real-time assessment of adherence to the Dimes method. So I am writing down my problem case with a group of students, just like I would in a Google Doc. I open the chatbot and I say, hey, can you tell me if I'm doing okay? And it will go through the assessment rubric for adherence, and it will tell you, okay, you've written 6 stakeholder groups, you should only have 5. Or you've written 2 effects, you should have 3 to 5. Or your table of cause and effects doesn't show how this cause is related to any effects, or something like that. Okay, so that's very helpful because that can save the instructor a lot of time. A lot of the student questions, when we give students an assignment, a lot of their questions and a lot of the time spent is just them reiterating and getting approval and confirmation that they have actually understood the assignment, that they are doing what's expected of them. And this helps to save all that time. But again, you have to have very clear instructions in order to do that. And the generative AI actually forces us to think through everything. So when I showed you, for example, for the systems thinking, this is the instructions just for one system element, just for input. These were not the instructions previously when I was doing it with my colleague without generative AI. They were a lot shorter. With a generative AI, you have to really spell things out because it doesn't have contextual understanding. So for example, if you see here, it says, let me just zoom in. It says, okay, for some reason it won't let me zoom in here. But what it says here, it says a score of 0. How do we know that we give a score of 0? Well, previously I didn't have to write that down for me and the other human that I'm working with, because it was clear if it's not 0 or 2 or 1, sorry, if it's not a 3 or a 2 or a 1, it's a 0. But this was not clear for the generative AI. It did not give a 0 to anything. So I had to actually explicitly tell it what to give a 0 to. So again, the Dimes GPT can help us with all kinds of things, or the generative AI in general. And we've got the platform, which is currently working. And we've done a few pilots already. So one pilot that we did was a remote workshop with people from 3 different universities. And another one was a remote course that I taught over an entire semester when people use this platform. And we gave some surveys and so on. There's still work to be done. We have made some changes as a result of these feedback. However, there are still generative AI capabilities that I would like to add inside the platform. For example, calculating these efficiencies that I've showed you here is not something that can be done on the platform right now. It's something that you will need to do yourself or use my application expert GPT. So that's something that I would like to have inside. Another thing I would like to have a chatbot, a facilitator for the instructor, not just for the students. So something that would help the instructor and summarize reflections for them and help them to basically manage the process for the students. That just needs more budget. So we asked them about what they enjoyed, what they didn't enjoy, what they understood. Overall good results, but as you can see, not perfect. And we also did user experience interviews. So we actually interviewed instructors who use this. And I didn't actually do the interview. The person who did the interview is actually a user experience researcher. She's an expert in this stuff. And, we found all kinds of pain points, things where, people got stuck and so on. I'm not going to belabor it, but it's just to show you that, these are important things to do if you want people to use your generative AI applications. You need to do some kind of user testing. You need to really see what people think about it. And you need to approach it as an education research. That would always be my advice. Okay, so we've come to a break now. And before we go into the reflection or the break, does anybody have any questions for me, please, on any of these topics that we discussed? If not, then I will go on to the next activity, but I'll wait for some questions just in case.
I have a couple of questions. So the framework is extremely interesting, and I guess it's intuitive. My question is how creativity kind of emerges if someone applies this methodology. Because
Yes.
I sense that it's more about like how creatively one can kind of combine ideas from different domains and come up with specific solution for the problem. That's the whole motivation, like one of the motivation of this work, I think. So are there any measures which kind of methods which have been proposed and evaluated for this work?
Yeah, so there's two frameworks that I presented. I present a framework on introductory systems thinking, which is how to describe artificial systems, also how to prescribe or design artificial systems, and getting students into that. The second framework has to do with taking an ill-structured problem and structuring it so that you can focus and then come up with solutions. So on their own, they facilitate opportunities for creativity. They are not themselves creative frameworks. So with the systems thinking, for example, I can ask you to describe this system and then ask, okay, can you improve any of the outcomes of this system? So there's, say, a benefit that you've identified with this system, or there is a detriment to this system. Can you find ways to increase the benefit or reduce the detriment by changing one part of the pen? How does that then affect the different interactions of the parts in the pen, and how does that affect the interactions of the pen with other boundary systems, with the inputs and outputs? So that is room for creativity in that you're using the systems thinking framework to think about this thing as a system, and that can give you a different approach to how to think of ideas for improving the system, for how to do design. So, for example, once you understand that, oh, there could be other input systems or output systems, or I could change something about the architecture and that would change the entire function of the system and so on. So that is something that can be helpful in thinking about different designs. And I mean, I can give other examples for that as well. It may be actually a better example is this one. What I showed you here.
Direction can be, let's say, this is the working system for this particular specific problem, and where else you can replicate the same or maybe part of it.
Yeah, so for example, what you see here, this was a solution that the students came up with. Okay, we have this very hot, very heavy brick of molten salt, and we need to transport it somehow from the truck to a person's house. And there's a lot of rugged terrain on the way and all this kind of stuff. So the trolley that they came up with, that's the architecture. But the really smart part is that this trolley is brought outside of the house, is brought into the outside perimeter where there's a fence. And in the fence, there's a little hole, which is usually used for garbage collection. This is actually a boundary system. So somebody can come up from the other side, you know, someone with like a proper like carrier bag to carry this brick so it doesn't break their back, right? So it doesn't cause any problems. And they take this brick and they put it on the trolley through this hole. So the idea here is that, okay, so we're using this boundary system of the fence as part of the function of our system. You could remove that completely and you can say, let's just have a delivery person bring the brick inside the house, right? Or put it on the trolley or whatever. So you can play with it in different ways. You know, what is your system of interest? What are your boundary systems? And you can play around with that. Now, when you use and I've actually started doing this with students, when you use the GPT, so the GPTs are things that you can create in ChatGPT. You need a premium account for that. You need the $20 a month for that. That's what it is in the US anyway. And then what I uploaded all the different documents about this framework to this GPT. So now it's trained on those documents. And now I can just put in like a Wikipedia article about a fast train in Japan or something. And I can say, describe this system using this framework, the system that's in this article. And then I can say, okay, I want to make the train faster. Can you suggest ways of changing different parts? And then I can delve into that and learn about it. Okay, why did it suggest, what about, does this part really work? Does this really work? What about the material? What about this? You can really create like a whole lesson, you know, and learn a whole new thing, you know, learn entirely new concepts, just playing around with this idea of let's take an existing system, describe it, and now let's try and find ways to redesign it so it can increase the benefit or reduce the detriment or introduce a new benefit or what have you. And in terms of dimes, the problem structuring, where does creativity come in? So the way creativity comes in is after we structure the problem. So after we structure the problem, we want to come up with ideas for solving the problem. And that's when we can really play around with a lot of things. So for example, we can look at the problem statement we've come up with and we can say, what are some things we're assuming about the problem? That they're not written, they're not explicit, but they can be inferred. Okay, so just to give you a quick example, I once did a workshop with students from 8th grade. So they were 14, 15 years old. And the problem I gave them is that people drop their smartphones all the time. And this was 6 or 7 years ago. The cases were not as good as they are today. Even today, there's a lot of problems. So people drop their phones all the time in all kinds of places. And what happens is your hand leaves your phone falls to the ground, it hits the ground, and it causes damage to the phone. Everything that I've just said has assumptions. One is that when my hand leaves the phone, it falls. The second one is that when the phone falls, it falls down. And then when it falls down, it hits a surface and it gets damaged. It doesn't have to get damaged. It doesn't necessarily have to fall when my hand leaves it, and so on. So one of the students came up with this idea. Again, we wrote down all these implicit assumptions and we shared them. And then using those implicit assumptions as inspiration, one of them thought of this idea of having like a bracelet, and you can have it like as a Bluetooth or something, that it senses when your hand does this motion, like your tendons here, and then it operates some kind of a parachute from the case. Now, it doesn't matter if it's very feasible or not. It is a creative idea, and they got to this idea by making an implicit assumption explicit and then challenging it. So this is something that generative AI is really good at, and this is built into Seed AI, but you can do it on ChatGPT. You can put in the problem statement and say, tell me what assumptions am I making here about the problem. Another approach is by analogy. So you can ask the generative AI to find other problems that have been solved to some degree that are analogous to your problem, and they can be in a completely different domain. For example, again, this is another true story, an emergency room in a hospital. I think this was in New York State. They wanted to reduce the time that it took to process people who come into the emergency room, because the time is very precious in the emergency room. If you can divert somebody to get the right treatment 10 seconds faster, you can save their lives, or you can save part of their body, or whatever. And they looked around what other hospitals are doing, and everyone's doing more or less the same thing. So you can't really change that way. They hired a consultant. They took them to a Formula One racing track. So this is car racing. This is not hospital. Completely different domain. And he took them to what's called the pit stop. The pit stop is where, as you are racing, every once in a while, you stop your car and you get taken to the side to have your tires changed, to have your refueling and all of that. The people at the pit stop, the people who work there, they don't just know what they're doing and what the roles are. They know physically where they stand, where they're going to move, who they're going to give what tool to, what they're going to do now, what they're going to do next, who's doing what. Like, everything is completely regimented. So this was taken as an analogy for the emergency room in order to make things even more regimented and even more time efficient. So this is an example of solving by analogy. So this is another thing that generative AI is really helpful with. So again, this idea of giving prompts for the problem, giving you different perspectives on the problem, whether it's implicit assumptions, whether it's analogies, and there's other examples, other exercises too that I can talk about. Generative AI is really helpful because if you ask a person to come up with 5 analogies for the problem, they're going to have a hard time. But the ChatGPT can do it like this. And the nice thing is, for these assumptions and analogies, it doesn't make a huge difference how correct ChatGPT is with giving these analogies and assumptions, because the whole idea is just to give you a different way of looking at the problem. Another thing which it can do is actually just to give ideas. I don't advise doing that exclusively with ChatGPT. Again, because it's not going to be necessarily original. Also because it's good for us as people and as students to practice our own thinking. So I always suggest to augment the human thinking with the AI when it comes to ideas. There's no reason not to ask it for ideas, but think of your own ideas first. Don't get biased by the ideas of the AI. So as far as creativity goes, I would say generative AI is a great creative companion. I would definitely not use it to replace human creativity.
Thank you so much, sir, for the detailed answer. And I feel not just generative AI, excellent teachers like you, they are also very good with come up with nice metaphors. Like your example of pen was very good, and we could relate very nicely with the concept of it. So
Thank
I
you.
think one of the finest use case of generative AI is to use means of course faculty members can ask for metaphors before going into the class so that they can kind of based on students' interest, of course, so that students can relate very nicely with the whatever topic they are going to talk. There is one more question from the chat box. The question is like this: the framework is interesting. Is it? And the person is talking about SAPO framework. Is it applicable to all kinds of problems or the problems that fit into the structure which you have mentioned? And the question is from, if I'm pronouncing properly, then Pensis Buddha. Please. Yeah.
Thank you. Yes. So let me divide it into my answer into two. So we have DIMES, which is a method for structuring problems. So you take an ill-structured problem as a problem description, and you explore it, investigate it, research it, put it into a model, extract efficiency points, summarize it, and you have a problem statement, which is a well-structured problem. That well-structured problem can go into, one second, where it says outcome here on the right, and it says problem. That would be a well-structured problem because we know what it is. We can define it. Sometimes we're not sure. So for example, if I take the bicycle and I said that the bicycle, okay, so there is, if we take the bicycle as an example. So here I said that the problem, walking takes too long and using a car is too expensive. Okay, of course I can make that a lot longer. I can make that like 150 words, but you see that I have specific stakeholders in mind. Urban dwellers who reside outside of their city center. So I have a specific group of people and I have a specific problem. Now, when I say detriment, higher vulnerability to dangerous accidents, who has higher vulnerability? Is it the cyclists? Is it the pedestrians who have a higher vulnerability? What do I mean by higher vulnerability? Why do I mean by dangerous accidents? I can go into that more, right? So generally speaking, when we are describing a system and we want to describe the problem that it's solving, it should be ideally a well-structured problem, because that means we've understood the problem that it's solving. If it's not, if it's ill-structured and we don't really quite understand who the stakeholders are or who the main stakeholders are, we don't quite understand what the problem is, then we can use DIMES to figure that out. The way you can use both is you can use DIMES to structure a problem and then design a system to solve that problem with Sappho. So again, you start with the outcome. You say, okay, I have these stakeholders and this is their problem. I have a problem statement. Now I want to figure out, okay, so what benefit do I want to provide them, which is the inverse of the problem? And then based on that, what function and what architecture can I come up with? So that's kind of how they come together. But generally speaking, when we talk about problems in Sappho, we are talking about well-structured problems. Now, the detriment that I said before, every time we solve a problem, we inevitably cause at least one new problem. That doesn't mean the new problem is worse, but we have to be mindful that we are creating new problems. So in this case, maybe we now have to go and structure this problem because it's ill-structured, this detriment. Detriment is also a problem, right? Which we might build another system for or redesign our system. But we might not understand it well enough. We might not understand the detriment well enough, in which case we do need to go and structure it. It's a question of, you know, when you're faced with an ill-structured problem, like this one, it's overwhelming. It's something that usually is, you need a lot of resources to tackle. And the idea of structuring a problem is being able to focus on the most effective or most efficient points in the problem. That's the way I look at it. Is to have a better understanding, yes, but it's to have a better understanding in order to be able to focus on very particular parts where you can have the most impact. because solving the entire problem is usually very difficult with ill-structured problems. I know I will take more questions. I just want some people, if possible, anyone who's interested.
Like,
yes.
Participants can also, if they raise their hand, they will unmute them. They can also speak. And also,
Oh yeah,
Professor
please.
And also Professor Vineet Saula is here. He is the chief investigator of our academy, EA and ICT. So, sir, if you want to say something. Yes.
Yeah, happy to, please.
I have a couple of questions, but I guess I will ask them afterwards.
Yeah, good morning, Ria.
Hello,
we
good
thank
morning.
you. Thank you very much for your time and efforts. Yeah, I'm
welcome.
enjoying your talk. I'm enjoying your talk. Please carry on. Thank you.
Oh, thank you so much. I appreciate that very much. Do you have any more questions, my pal? If not, we can go maybe to the reflection exercise and some more discussion.
Sure, sir. First, we will go to reflection and then we can take other questions.
Great. So just to summarize everything I've shown you in terms of the generative AI aspects. So I've mentioned before that instructors have a lot of challenges when it comes to implementing active learning. And that is, for me, that's the key reason why there isn't more active learning happening at different institutions. It's because it's difficult. It's a difficult type of pedagogy. And everything that I'm trying to do with the frameworks I'm developing, but also with using the generative AI, is to lower that threshold so it becomes easier. So one thing has to do with judging the effectiveness of active learning. How do we know this is even working? So again, we have assessment rubrics for every single step. We divide it into adherence and correctness, so that's very helpful as well. And as I've mentioned, I've already got some papers published with validity and reliability assessments for these rubrics. And finally, we can use generative AI to do the assessment of adherence. So that's very useful because that cuts by 50% the time that we need to spend on assessing the student's work. Required preparation time. Another thing instructors are concerned about, a lot of preparation that needs to be done for problem-based learning. So again, now there is a platform. I can create a project for you in 20 seconds. There is a workspace that is very streamlined. If you don't want to use the platform, you can just use Google Docs. I can show you how to do that. That's what I used to do before I had the platform. It's very straightforward. Or Microsoft Office, or any other similar platform. Student resistance. Sometimes the students don't want active learning. They want the lecture. It's what they expect. Not because they are experts on their own learning and they know the lectures are better, but because that's what they expect. Now, the workspace and the chatbot and the reflections do help somewhat to lower that resistance. It's something for them to interact with. It's something for them to be able to think through what they've done and reflect on it. And some students find that very helpful. And something that I'm working on now is the reflection analysis in generative AI. So being able to take, 20 student reflections on one step, like the problem case, the inquire problem case step, seeing what everyone wrote and identifying patterns in that. And finally, we have the lack of instructional expertise in active learning, which I mentioned before. So for this, we have the full methodology. DIMES has full instructions for each step, assessments for each step, reflections for each step, the platform, everything there to walk the instructors and the students through. And now I'd like to take 15 minutes, and feel free to do this or not do this. Feel free to do it in the form or just do it on your own or think about something else. But I want us to maybe have a bit more of an in-depth discussion. So if you could pick one of these three questions, or both, or all three, but with the 15 minutes you have, maybe just focus on one to begin with, and just submit your answer to this question in this form. And again, if you don't want to submit the form, you can just write it for yourself. But if you do submit the form, then I'll take everyone's responses and I'll ask ChatGPT to identify some common patterns. So in 15 minutes, we can have a nice discussion. So if you could just take the next 15 minutes and I'll come back in 15 minutes. Meanwhile, I will answer questions. So while you are doing this, if anybody has any questions, please let me know. But I'll now put on the stopwatch for 15 minutes and we'll have a discussion about these questions in 15 minutes from now. And let me just quickly check that everything in the form works, should work. Yes. And meanwhile, I will also leave my email address here. So anybody who wants to contact me after this talk is welcome to do so. And let me share my presentation again so I can show you the reflection questions. And I do suggest all of you think about these, even if you don't submit the form. Just think about these questions. And generally speaking, I will always say with generative AI, if you understand what you're doing, then you can usually use generative AI to help you with it. Help is usually save you a lot of time, sometimes even to improve the quality of what you're doing. But it has to be something you understand really well so that you can prompt it well and you can also check its answers. So for me to get to the point of, having a GPT that I rely on has taken a very, long time and a large amount of work because I have very detailed assessment rubrics and instructions. So there is not much room for interpretation. Where there is a lot of room for interpretation, that's where I leave things, to the humans. But certainly in terms of just following the guidelines for a specific step, no reason for the instructor to waste their time. No reason for the TA to waste their time. If the rules are clear and the guidelines are clear, generally speaking, it's something that generative AI should be able to do. And I think this is really unlocking for us a new era in teaching and in instruction. Because previously, I think we were very limited in our ability to give feedback because it just took too long to go through everything. But now I can spend all my time going through just the validity, just the correctness of what the student wrote. I don't have to spend a lot of time on, did they write the right number of parts here? And did they go over the word count? Or did they explain why they chose this efficiency point over another? All these things can be checked by the generative AI and they can get the feedback from the generative AI, make all the corrections, and then I can go over the work. So it's very helpful. And of course, we can go beyond that. We can use it as a brainstorming partner, as I explained before. We can use the generative AI to give us different perspectives on the problem, or give us different configurations of our system, or try out different ideas. There is really a lot of things we can do, and things that we haven't even spoken about today. So we'll come back in about 8 minutes to do the final discussion.
Sure, sir. You can also take break for 8 minutes if you want.
Okay, I will do. And when we'll come back, I'll take the answers that people have submitted. And I won't show a particular answer, don't worry. I'll just show like summaries. And we'll go over these questions and begin discussing them and other things. Any other questions anyone has?
Sure, sir. Thank you. Thank you. Very good.
Hi, everyone. Let's just take 2 more minutes. If you could submit your reflections, if you're so interested, and we'll talk about a summary of those responses in a couple of minutes. Okay, everybody. Thank you. I see that there are more responses coming in. But I'm just gonna share with you my screen here so we can see together what people have come up with. So if we look at the first one, how might you use generative AI in your teaching? So we've got some people talking about teaching and learning enhancement, to understand difficult topics, to generate metaphors, visualization, summaries, and lecture notes. So this is quite interesting. This is to do with the tutor role of generative AI, as well as with the co-creator, but in this case, a co-creator with the instructor. Content creation, instructional design, again, as a co-creator, assessment and feedback, creating quizzes, research and problem solving. That's very interesting, using generative AI for research. And somebody wrote that they don't use it, and that's fair, of course. The second question was, how might students use generative AI in their learning? So one thing has to do with concept exploration and understanding. You can certainly use the SAFA framework, the systems thinking framework, in order to explore, a certain system of any kind. Feedback, evaluation, and reflection. Yes. Creative ideation. Assignment and presentation support. That's interesting. So the idea of improving presentations with generative AI. I don't actually know anything about that. So I'm happy if somebody has anything to share. How we can use generative AI to improve presentations. I mean, I know we can create images with generative AI, but maybe that's not what they mean. Study aids and revision tools. Yes. I don't know if if you've heard, there is a Google product called Notebook, one word, Notebook, LM. And what you can do there is you can upload, papers and resources, and then you can ask, among other things, to actually create a podcast where it's two artificial people talking about the topic. Gamma is used for PPT. Somebody is saying Gamma, G-A-M-A. Thank you. I've not heard of it. There's so many tools out there, right? It's hard to keep up. So this idea of the interactive podcast, what's cool about it is that you as the user can actually interfere with the podcast and ask questions. And you can even do this with voice mode. So it's a pretty cool thing. Third question was, what practical applications do you see for the generative AI tools and studies that have been presented? So it's more specifically about not just generally for teaching and learning, but if there's anything that you saw today that you might be interested in using. So assessment and feedback systems, track learning progress, offer personalized insights. Yes, you can definitely use both frameworks for that. Learning process management and analytics. Okay, this is very interesting. So as I've mentioned before, with the Seed AI platform, with the DIMES method, you can add your own learning materials. You can add readings, you can add quizzes, you can add other forms, you can add additional work to each step. And this is something for sure, if for example, you wanted to track a certain attribute, like let's say the writing quality, or critical thinking, use of critical thinking, you can actually follow that up on every step. And as long as it's well structured, you can actually just feed all the student work into the generative AI and say, okay, here is the definition of critical thinking, or here's a rubric, how to evaluate, how to assess critical thinking for each one of these steps. Now I want you to do that for me. And you can sort of track that for every student, and so on. So that's definitely something you can do. Intelligent tutoring and mentorship. So this relates to the tutor role, but also to the coach role. And the difference is the tutor role of generative AI has just to do with, knowledge and skills, a particular thing that I want to learn. Coaching has more to do with your learning process and reflecting on your learning process and engaging in metacognition. I find these kind of topics difficult and these kind of topics I find easy. Or I tend to do well in these kind of exams, but not in this kind of exams. How can I improve? Let's build a learning plan together. That's more what the coach does. And as we saw, there are actually fewer studies on that than there are on tutoring, on just straight up, here are the fundamentals of how generative AI works. Okay, and now I'm using ChatGPT to learn about how generative AI works. That's a lot more common than coaching me through working on a project with generative AI, let's say. And less well structured, and it's people's emotions and other things. Whereas tutoring, as long as the topic is well taught, tutoring, we already have frameworks, we already have very clear progression of how to teach something, with most topics. So it's a lot easier to use generative AI as well. And remember that the large language models are using the internet. So when they are teaching you something, yeah, very, very interesting. A lot of really, whether you're using, the frameworks that I taught you, the idea is that generative AI is very useful for helping to take time off of the instructor for how to follow instructions, how to follow guidelines. You just have to make sure that you are yourself very clear about what those guidelines are, so you can spell them out for the generative AI. So that's something that generative AI, for me, is something that I put a lot of confidence in, and I think is a real game changer, because giving formative assessment takes a really long time. And if there are certain aspects that we can offload or automate, that will be really great. And it'll be really great for the students as well, because they won't have to stop their work, every 20 minutes to ask a question. They can just very quickly ask the generative AI, get an answer or get feedback on what they're doing, get course correction, and spend more time actually working on understanding the topic, on getting things correct, looking up valid sources, and so on. So it's really great, again, for assessment of adherence. It's also really great to help us with brainstorming. I wouldn't say to give us ideas, but to help us think differently about the problem. It's also another thing it's really good at. A third thing it's really good at is summary. It's summarizing things for us. But again, we have to make sure that we already know the material, because it won't necessarily always summarize things in the best way that we want. We need to tell the generative AI what to pay attention to. So the important thing is, again, whatever you are teaching, whatever concept or skill you are teaching, have a very clear idea of what it is you want to teach and how you're going to evaluate student work. Once you have that clear, then you can use generative AI to help you with a lot of things. But if you if you stay on the ill-defined level of what it is you're teaching, and the things are not really spelled out, generative AI is not going to be very useful. So that's kind of, my take-home kind of message for all of this, is that the frameworks, the pedagogical frameworks, are very important. And if we want to use generative AI effectively in our teaching and in learning, then we need to be very clear about the framework that we're creating, because the generative AI has no understanding of content. So yeah, that's really all I wanted to say about that. Does anyone have any questions otherwise?
Thank you so much, sir. I have a couple of questions and observations. The first one is, of course, you have mentioned that the creation of, if we go for custom GPT, then we have to go for the plus version. But I guess 2 weeks back, Gemini also provides that gems which we can create, and now they also allow it to kind of make it shareable. So we can create gems and share it with others. So
Yes.
do you feel that gems can be kind of alternative of custom GPTs in case if someone doesn't have plus ChatGPT plus subscription?
Yeah, this is just what I remember. I mean, I have the link to share for both GPTs.
I was about to ask that in case if your GPTs are public, then or
Oh,
maybe
yeah, for sure.
so but then only we'll be able to kind of learn even better because we can actually give
Yeah,
some.
just send me an email after this, and I'll send you both links happily. I just, again, I don't know. I think you need ChatGPT Premium to access them.
No, accessing is free as per my law. Because
It's free? Okay. Okay.
Accessing is free, but
Okay. Yeah.
we
So I can
create
send you the
a
link to both the systems thinking one and the problem structuring one.
but I'll check. It's not public, I guess. It's shareable only, right? You have kept it like unlisted, only with link one.
Yes.
Yes.
Yes, I have that. Yeah.
It's a second question is AI. Because of AI, the education landscape is changing very fast. So we all of us can sense that prompt engineering and knowledge of some core AI tools is one of the essential skills. Apart from that, all of us feel that in India we don't give too much kind of importance to problem-based learning. But in now, since the kind of one can say since the last 2 3 years, because of this AI developments, now it's even more important to kind of have this particular concepts in our formal curriculum. So what are your suggestions on this? Like what are the key skills which one should kind of incorporate in at least for first year undergraduate students? Like programming is there. Programming is of course for everyone nowadays. Like English is kind of new programming language, and the gap is kind of becoming smaller and smaller because between the actual product idea and the actual product. So what are your takes on this?
Yes. So first, I put the links to both the GPTs in the chat, so anyone can, as long as you can access it, feel free to use it, and I'll be very happy to receive feedback as well, because these are pretty new. So my general advice, and this is how I work with people in my department as well, is that every teacher, lecturer, instructor, professor should think about a assignment-specific generative AI policy. What I mean by that is, if you're teaching a course on anything, it won't make sense to have the same generative AI policy on everything. Because, for example, if you say, I ban the use of any generative AI, you can't use any of it. You can't actually monitor that. So the students who are honest and decent will not use it. The students who cheat will use it and probably gain from the fact that they're using it and might get a better grade. So it's not really ethical to say, oh, nobody can use it, because you cannot enforce that. Unless the actual country you're in doesn't, but then it's an irrelevant question anyway. You can ban the use of GPT by saying, for example, we'll have an exam in the classroom and you won't have access to the internet, or I will provide you with a terminal to an internal computer system in the university or something. Then you can make sure they're not using generative AI. But most hours of the day, most days of the week, you can't control that. So you need to look at every assignment in your course in this new age of generative AI, freely available, and say, okay, what here do I want to have students use generative AI for? And now I have to think about how to integrate generative AI into it. What here I don't want them to use it, and I need to then make sure that they can't use it in some way, right? And then what do I want to make it optional? So you can use generative AI for this assignment, but you don't have to. But if you do, in any case, you have to report on how you used it, so we can all learn from you. There is a fourth type of assignment, which is an assignment that cannot be solved with generative AI, even if you use generative AI. So you're not allowed to use it, but it doesn't matter because you can't use it anyway. And then I can have you do it at home. It doesn't matter. That's more difficult to do. It is possible. I have some examples of that. Like you can use an esoteric concept, or you can use very specific value that isn't found in any example online. There's different ways you can do it. But what you got to do is you got to look at your syllabus, you got to look at all your different assignments, and you got to think about, what is my generative AI policy for each assignment? Do I want them to use it or not? Or is it optional? And how do I want them to use it? I might want him to use it by for example, if it's a reflection assignment, I always say, you have to write it, not the generative AI. If it's a reflection assignment. But you can use generative AI to maybe give you feedback on your own reflection. Or check for spelling mistakes, maybe things like that. But in a reflection, that's not even important. But if let's say they're writing a report about their design or something, I might allow them to use generative AI to actually, I might not mind if they use generative AI to actually create the text, as long as what they're presenting is correct, because I'm not testing them on their ability to write necessarily for this class. So it depends on your learning objectives, is all I'm saying. I don't think there is no justification with saying never use generative AI to write anything, or no, it just depends on what you are actually looking for in the class. If my class is not about writing, then I don't care that they use generative AI to write. I care if they use generative AI to write and they don't bother checking anything and it's wrong and it's got nonsense in it. But I don't care if it's your voice, your authentic voice or not. Again, it's a question of what do I actually care about in my particular course. So look at every assignment and decide whether you are not allowing generative AI, you are demanding the use of AI, or you are making it optional. And then always ask them to report. And what I try and do in my class, because most of the assignments are with AI, at least optional, I try and create a very open atmosphere so that we all just share about, how they're using AI, what worked, what didn't work. And through this, they begin understanding, they begin using their critical thinking, and they begin to understand that just using generative AI blindly is actually a very bad idea, and it's not going to help them. it might help them where they can, you know, cheat the system, but it's not going to help them with real life problems. So yeah, that's, you know, there's a lot to talk about here, right? But generally, I would say look into every assignment that you give your students and figure out what the best generative AI policy is for that assignment, not for your entire course, because that doesn't really work. I cannot hear you for some reason. Now I can hear you.
So we'll wait for participants' questions. If any. It was a wonderful presentation, sir. We also learned how to present. Your slides were extremely nice, visually also, and also in terms of content.
You're welcome. Yeah, so let me just finally share my details. So again, everyone more than free to contact me, check out my website, and we can, you know, talk about all this stuff. And thank you again for your time. I appreciate it. Have a good evening, I think, where you are.
Yeah.
A good night.
Yes, sir. It's 7 o'clock in the evening here in India. So, thank you so much.
Hey,
It was
take care.
It was a memorable session for all of us. And I guess a lot of participants will kind of ask you a lot of queries afterwards. You have already shared your email address, so they will contact you. Thank you so much.
Sounds good. Thank you again for the invitation. I appreciate it very much from the institution and from you, Maipal, as well.
Thank you so much.
Bye-bye.